Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about the possibility of analysis and design of oceanographic moorings on other moons in our solar system. For example, if we look at the moon of Europa, it has an icy crust and a very large subsurface ocean. In this case, some things you have to be aware of is that there's a very different gravitational constant, and if you're doing an analysis, you're probably going to be looking at a system that's anchored, ostensibly at the icy surface with the mooring hanging down into the water column. So there's a couple other things to be aware of and a couple of pitfalls I want to point out as well. Now, most of the time, people are designing oceanographic moorings for Earth. So when we look at the parts library, for example, there's a bit of a gotcha here where a lot of components, if you look at an Oceanographic Designer and then you look in the parts library, if we just sort of, for example, pick an instrument that we want to attach here, a Seabird CTD, you'll see wet weight, and it has a certain either factor in kilograms or whatever, and this is interpreted to be a number that's measured on Earth and not relative to another entity in our solar system. So you have to be a little bit careful about that. Nevertheless, you can do a lot, and what I'm going to do, it might be in some ways easier to look at directly setting up an analysis in Simulation Toolbox. So what I've got here is a very basic mooring. It just has a line, and we have a little depressor weight on the end. You have to think a little bit, again, upside down and having the anchor at the water surface, and there's more than one way to set this up, but I've followed a similar pattern to what we've shown previously. That is to say that we have node N at the surface with the mooring hanging down. Now I added a little point mass model here, this depressor weight at that's going to be pushing things down, and it's arbitrary, but it has a diameter of 0.5 meter and density like this is something analogous to steel, so it's pretty heavy, pushing the thing down. I just have a very basic current profile with 0.5 meter per second just to kind of demonstrate what happens here. So here's the trick where we have the Earth's gravitational constant by default. It's a hidden property because, well, to be frank, people are not changing this every single day. But anyway, there it is. And if we do an analysis to see what this looks like, the static analysis goes pretty darn quick here, and if we just take a look at it, load this up in PostPDS, look at it from the east in orthographic and engineering view. You can see there's not a lot of deflection here. It's a pretty heavy weight and the current's not that high. You kind of get an idea of what the deflection is like. Okay, so what I want to do is if we look at, for example, Europa, you see a gravitational constant of 1.314. So if we go back here, reset this, and we'll just change this 1.314. What's going to happen is we're still going to have the same mass for these parameters in here, and that's fine. The weight from these, the force from gravity, is going to now be significantly reduced because of the gravitational constant. Buoyancy, on the other hand, will still be a factor of that displacement of water volume, of which you can set the water density in here. Maybe the density might be quite different on Europa, but you can make an change accordingly here. And then, of course, buoyancy is also scaled by the gravitational constant. So with the same current profile, with a much lower gravity, I expect to see a lot of deflection. So by specifying this model parameters with density rather than weight in water, we don't have to worry about getting confused about what the wet weight might actually be. We're directly specifying the components density, and then we can be confident about what we're seeing here. And the same goes for the line properties as well, which you can directly specify that way. So we'll just run this analysis, and again, I expect to see greater mooring deflection because we have less weight pulling it down, but the drag force is the same from the same current profile, the same geometry of the line. Okay, so we'll load this up in PostPDS again. Okay, and maybe just zoom in a little bit here. And there we are. We see, quite a bit bigger deflection. Still not that much, although it is a pretty big weight on the end of that thing. So, of course, there's lots of details you can get into looking at all the numbers and more specifics. But really, what I wanted to highlight both was the sort of pitfall. Be careful about when you're looking at the parts library with wet weights that are kind of determined in Earth's gravitational field. And then how you actually can go about setting the gravitational value. Now, again, this is a hidden property, so it doesn't show up by default, but you can just start typing and find it and then change the gravitational constant. Away you go. All right. Thanks for watching.